Okay, continuing with inequalities, we're going to look at compound linear inequalities. Now there are two types of compound linear inequalities, and I always kind of try to draw the comparison to compound linear inequalities to compound sentences. Two simple sentences connected with a transition word like and or. Well, compound linear inequalities are two linear inequalities, simple linear inequalities that are connected together with either the word and or. The word and refers to an intersection, or what we sometimes refer to as a conjunction. It means it has to be in both solutions, the answers have to be from both parts of the simple inequalities. Whereas a union, it's an or statement, a union or a disjunction, and it just has to be in at least one of the solution sets. So you're going to have two simple linear inequalities. You're going to solve those, and you're either going to be taking the intersection of them or the union of them based on the way the problem is set up. In this case, this one's a union. This has got the or here. So I solve this, and I solve this, and I take what is in both. Not what they have both in common, but everything in both. It has to be in at least one of them. So let's go ahead and start this one off. I'm going to write my, it says solve, but I'm going to write my answer in interval notation. It's convenient that way, and I'll even draw out the graph on the number line. To solve this is very simple. I'm going to multiply both sides by 4, and since I'm multiplying by a positive, I do not need to reverse the order, and I get y is less than negative 4. Or here I'm going to get rid of the positive 3 by subtracting 3 from both sides, and I have y is greater than or equal to 2. Now if I draw this on a number line, put down the two key values of negative 4 and positive 2, make sure they're in the right order, and look at what the graph would be if I graph both of these, because it's an or, I want the union, I want everything from both. If I graph both of these on my number line, this is less than negative 4, so that's a parenthesis and shade to the left. This is greater than or equal to 2, so that would be a bracket and shade to the right. They don't have to overlap here. I'm taking a union, so my solution would be, that's a 4 there, although you couldn't tell it, would be from negative infinity to 4, or excuse me, negative 4, parenthesis, and from 2 to infinity, bracket there at the 2. And to show that it's both, I put the union symbol, set symbol right there. And that is how I'm going to write my solution to this compound inequality. Now the one that's above here, this is an and. It's also pretty straightforward as far as solving. I threw in a couple of decimals just to make it interesting. But I'm going to go ahead and I'm going to solve this, and I'm going to solve this, and I'm going to take the intersection. What is common to both? And in this case, 0.36w divided by 0.36 less than or equal to 0.54 divided by 0.36. I get w is less than or equal to, it looks like 1.5. Over here, I'm going to multiply both sides by the reciprocal, which would be negative 2, and by doing that I have to reverse the order. So this becomes a less than, and I have negative 2 times 3, and I end up with w, well, let's see if we can bring this down a little bit to line it up here just a little bit. I have w is less than negative 6. Now what I'm going to do is not draw them both on the number line at the same time. With the ands, what I like to do is I like to put them above the number line so it's easier to see where they overlap, because that's what I want, what they have in common, what they share. So I'll put down the two key values. I'll get the pen here. This is going to be from 1.5 bracket less than that, and this one is going to be parenthesis negative 6 less than, and to the left. Do you see where they overlap? They overlap right here. Values less than negative 6. We don't include the negative 6 because it's not included in this part. Even though it's up here, it's not included in this. So the solution turns out to be on the number line, this part of your graph, and that is from, let me write it with the darker colored pen here, from negative infinity to negative 6, parentheses. And that's my solution to this compound inequality. Now this is a compound inequality, although it doesn't maybe look like a compound inequality because you don't see the word and or, but this is an extended inequality or three-part inequality, and what I do here is I can write this as an and, as an intersection, because it has to be true for this, negative 16 less than or equal to negative 3y minus 4, and it has to be true for this, negative 3y minus 4 is less than 2. Now, when I was a student in school, I would break it apart and write it with an and statement. I would actually write it out, negative 16 less than or equal to negative 3y minus 4, and negative 3y minus 4 is less than 2. I find that that's a lot of extra work. I think you're better off just working with the extended inequality here, but if you're going to add or subtract or multiply or divide, whatever you do to isolate the variable here in the middle, you're going to have to do to the ends as well, all three parts. So let me kind of erase this and get this guy out of my way. You can use this will work, but I'll show you a little bit faster, more efficient. Now there's my variable. It's being multiplied by negative 3, and there's a 4 being subtracted. So the first thing I'm going to do is get rid of the minus 4 by adding 4. Now notice I add 4 to the left, I add 4 to the middle, and I add 4 to the right. So that gives me negative 12 is less than or equal to negative 3y is less than 6. Now I'm going to have to divide by negative 3 to get the variable y by itself. And remember, if you divide by a negative, you're going to reverse the order, and since I'm going to divide all three parts, I have to reverse both orders. So this is negative 12 divided by negative 3 greater than or equal to negative 3y divided by negative 3 greater than 6 divided by negative 3. 4 greater than or equal to y greater than negative 2. Now there is absolutely nothing wrong with it written in this form, but I'm a traditional kind of a guy, and the traditional kind of guy, extended inequalities, we normally write with less thans and less than or equal to's. There's nothing wrong with this, this is fine, but I'm going to rewrite this. I'm going to kind of flip everything around. I'm going to bring the negative 2 over here, less than y. See how y is greater than negative 2? Negative 2 is less than y. Less than or equal to 4. I'm just a little more comfortable with it written that way because when I look at this on the number line, negative 2 is to the left of 4 on the number line. So if I look for a sketch here, and I'm going to write this, notice a parenthesis here, there's no equal to. Bracket here, there is an equal to. And I want everything in between. Just like the y is between the two values, I want the graph in between. So that tells me in interval notation that my solution set would be from negative 2 to 4, bracket at the 4, parenthesis at the negative 2. You would get the same answer if you did this one using breaking it apart and writing it with an and. It's just more convenient, I think, if you go ahead and work with the extended inequality. Now, the absolute value inequalities, they're pretty much the same thing as the compound inequalities, because when you have an absolute inequality for k greater than 0, if the absolute value of the expression is less than k, notice you get an extended inequality, a conjunction. And when the absolute value of x is greater than k, you get an or statement, you get a disjunction. Now look at this. Because the absolute value is less than k, see how this expression is between k and its opposite. But here, when the absolute value of u is greater than k, means either u is greater than k, or keep the left side the same, reverse the order, and take the opposite, u is less than the opposite of k. Now that's a lot to remember, but it's something that you've had back in your algebra days, so it shouldn't be all that brand new. I have an example here. It says solve the inequality and write the solution set in interval notation. And I have an A here. I don't have a B written down because I didn't have very much space. I may have to erase a little bit of this to show you a quick example of that as well, if I haven't lost my paper. So I'm going to isolate the absolute value symbol first. See how it's by itself? So that I can apply the rule. I have to undo the stuff around it. I have to get rid of the plus 2. I have to get rid of the 3 that's times it. So first things first, I'll get rid of the plus 2 by subtracting 2 from both sides. And I have 3 times the absolute value of 5 minus x is less than or equal to 12. I'm going to divide through by 3. less than or equal to 12 divided by 3, and I get the absolute value of 5 minus x is less than or equal to 4. Now this problem starts to look a little bit like what I was showing you, right here. I have this expression inside the absolute value less than or equal to my positive number 4 here. So I'm going to rewrite it as an extended inequality. I'm going to write negative 4 less than or equal to 5 minus x less than or equal to 4. And I can solve this just like I solved over here. I'm going to subtract 5. Didn't give myself very much room here. It seems like I do that a lot. Let's see, 4 minus 5. And I get negative 9 is less than or equal to the opposite of x is less than or equal to negative 1. Well, this is like a negative 1 here. I'm going to have to bring it up to here. I'm going to have to divide through by negative 1, which is going to reverse the order. This becomes greater than or equal to. This becomes greater than or equal to. And I get 9 is greater than or equal to x is greater than or equal to 1, or switching it around, 1 is less than or equal to x is less than or equal to 9. So on my number line, here's 1, here's 9. It would be including each endpoint, all the numbers in between, including the endpoints. So bracket, bracket, everything in between, and in interval notation from 1 to 9. That would be my solution. Now that one is an example of an intersection or a conjunction. I'll do an example of a disjunction here. Grab my paper. I'm still here. There we go. I'm still here, but I have the wrong paper. Let me grab another one. Here we go. Now I think we've got it. B here. Negative 18 is greater than negative 3 times the absolute value of 2y minus 4 absolute value. Now, first thing I'm going to do is isolate the absolute value. That means I have to get rid of the negative 3 that's times it, so I'm going to divide both sides by a negative 3. That is going to reverse the order. And I'm going to get negative 3 times the absolute value of 2y minus 4 divided by the negative 3 there. So that gives me 6 is less than the absolute value of 2y minus 4, or better yet, flipping the sides to put the absolute value on the left. So now it matches up over here with this guy. Less than and greater than or the other way around, greater than or less than and. Go LA. I used to have students write that down at the top of their test papers when they were being tested on absolute value inequalities. This is a greater than, this is an or. Now you cannot write an or statement as an extended inequality. You have to break it into two parts. This is going to be 2y minus 4 is greater than 6. It looks exactly the same as the original, except that I've dropped the absolute value. Or, now you leave the left side the same, you reverse the order, and you take the opposite. So if you remember those steps, you can write this without having to refer to the rule for the inequality each time. I solve each one of these and I'm going to take the union. So I'm going to start off by adding 4. I have 2y is greater than 10. Divide by 2. Y is greater than 5. Here I'm going to add 4 to both sides. I have 2y is less than negative 2. I'm going to divide both sides by 2. And I have y is less than negative 1. So I have this. And I'm going to write my answer in interval notation. So to assist me, I usually draw a number line. It doesn't have to be real fancy. Negative 1 and 5. And with an or statement, I don't have to graph above. I'm going to graph right on there because I want the union, everything. So that would be here, parenthesis to the right, parenthesis to the left. I think it's so much easier to write out interval notation if you have the number line to look off of, because that tells me everything from negative infinity to negative 1 and everything from 5 to infinity. Notice parentheses. And because I want everything in both, I'm going to use the union symbol.